Right now, Betelgeuse is still dimming, and NASA has no way to stop it. One of the brightest stars in our night sky is fading, right in front of us. The world's most powerful observatories have no explanation that holds. And here's what nobody is telling you: what happened to this star may be a warning signal they don't know how to read. Betelgeuse sits on Orion's right shoulder. You've seen it your whole life, that red-orange point just above the three belt stars of Orion. It is a red supergiant. A dying star roughly 700 light-years from Earth, so enormous that if it replaced our Sun, it would swallow everything out to Jupiter's orbit. 700 times the diameter of our Sun. One of the largest stars visible to the naked eye. Astronomers have studied it for decades because Betelgeuse is not going to last forever. It is a guaranteed supernova. Not might be, will be. The biggest explosion our cosmic neighborhood will ever produce. When it goes, it will burn bright enough to cast shadows on Earth in daylight for weeks. The only question has always been when. Then, in late 2019, it started doing something no one had predicted. Between October 2019 and February 2020, Betelgeuse lost nearly two-thirds of its visible brightness. Two-thirds. A star that has blazed reliably for thousands of recorded years suddenly dropped so far that amateur observers noticed it with the naked eye. This became known as the Great Dimming. NASA pointed every available instrument at it: the Hubble Space Telescope, the Very Large Array, ground observatories across 4 continents, all watching, all trying to understand what was happening to a star the size of a small solar system. At its lowest, Betelgeuse reached roughly 36% of its normal brightness. That is not a flicker. That is not instrument error. That is a massive, ancient star doing something that challenged a century of stellar models. And the data from Hubble contained something that made the room go quiet, something no one had expected to find at the surface of a dying star. What scientists found at the end of this is the part they're afraid to say out loud. The first explanation was the obvious one. Betelgeuse pulsates. It breathes, expanding and contracting on a roughly 400-day cycle. Scientists said it was a normal dimming phase. On schedule, nothing unusual, except the numbers didn't fit. The dimming was too deep, too fast, and concentrated in the wrong region of the star. Brightness models predicted a gradual fade. What they got was a sudden plunge. Then Hubble captured something that broke the pulsation theory entirely: an asymmetric dimming. The star was not fading uniformly. The southern hemisphere of Betelgeuse was dramatically darker than the northern half. That does not happen in a pulsation cycle. That does not happen in any model they had. But that's not even the part that worries them. Here is what Hubble actually found. In early 2020, Hubble detected a massive outflow of superheated gas erupting from Betelgeuse's southern face. A plasma plume larger than the distance from our Sun to Venus punched through the star's surface and rose into space. As it rose, it cooled. As it cooled, it condensed into dust. A vast, thick cloud of stellar dust formed in real time directly between us and the star. That dust blocked the light, not a dying star, not the beginning of a supernova, a star coughing, erupting, throwing its own interior into space and draping a shroud across its face. And here is the part scientists are not comfortable saying out loud. This scale of surface mass ejection was not supposed to happen to a red supergiant this way. Betelgeuse expelled material equivalent to several times the mass of our moon in just a few months. That debris is still drifting through space right now. The plume event was unprecedented. No existing model fully explains why the eruption was so violent or so localized. And when astronomers analyzed historical brightness records further back, they found something that made all of this worse. Betelgeuse had dimmed before. Deeply. Quietly. At times when no one was watching closely enough to record it. This was not the first time. We just didn't know. What this means for the science is serious. Betelgeuse is our closest candidate for a visible supernova, the only dying massive star we can study in this level of detail. If we cannot predict why it ejects mass on this scale, we cannot accurately model when it will explode. Supernova timing, stellar evolution, the late-phase behavior of red supergiants, all of it rests on understanding what this star does and why. The Great Dimming forced a fundamental revision of standard stellar mass loss models. It exposed a gap no one knew was there. We do not know how many times this has happened before. We do not know if the frequency is increasing. The star's pulsation cycle has been irregular since 2020. Scientists are watching more closely than ever, and they are not ruling anything out. So here is the question no one can answer. If Betelgeuse is ejecting this much material right now, possibly in its final phase, how close is the end, really? And if it exploded tomorrow, would we even have warning? Drop your answer in the comments, because this one is still unfolding.